Thought I'd take a minute and discuss a little bit of a new toy that I have. It's called a plasma cutter. I bought it a couple of years ago, and it's used to cut metallic materials, anything from small sheet gauge metal to a 5/8 thick steel. And in doing so, in order to understand how to operate it or make parts that you might want to form, there's a basic process called computer-aided machining that needs to be followed. Despite the machining process being used, it generally starts in the same process for any sort of computer numerical control work that starts with a digitized model. Now, I need to make one caveat here, and that is that I really wrote this or made this in intention to mechanical parts, but you can definitely do artwork in a very similar manner. Um, but I kept this to the mechanical end of things. And one thing that can be rather expensive for the home hobbyist is buying licenses for AutoCAD or some sort of drafting software to create sort of a flat file in which is used for CNC software to basically to create what are called tool paths. And I'm a cheap guy, so I went out and I bought an old Windows XP machine, and actually seem to have the old software and running old disks where I don't necessarily have to continue to purchase or renew licenses for some basic stuff that would otherwise cost me hundreds of dollars every year to renew licenses for. The prior screenshots that you just saw were from me using AutoCAD R14 and SolidWorks, which work on those old XP machines with static licenses. And real quick, what I'm showing you here is where the part is actually imported into a separate piece of software that generates tool paths based on uh, basically what sort of machining that you're doing. In this case, plasma cutting. And then what I'm doing here is just making sure that the parameters are correct for the material as well as the torch that I'm using. In order to make the cut successful. And obviously you can see there's some different parameters that you would be considering, whether you're cutting on the inside or the outside, cutting from the middle of the circle inside or from the outside. Makes a big difference in your finished dimensions. I'll pause really quickly and let my friends at Hypertherm explain what plasma cutting is.
If you're in the metalworking business, you've heard about plasma cutting systems. Plasma's combination of cut quality, productivity, and versatility make it one of today's most popular industrial cutting processes. But first, what is plasma? Plasma is often called the fourth state of matter. Let's take a look at the three other states we're all familiar with. They are solid, liquid, and gas. The difference between these states is their energy. When you add energy to ice in the form of heat, the ice melts and forms water. If you add more energy, the water vaporizes and becomes steam. From ice to water to steam. But what happens if you add even more energy to the steam? A lot more. If you could heat it to 11,700 degrees Celsius, the steam would break up into a number of component gases. It would also become electrically conductive or ionized. This high-energy ionized gas is called plasma. Plasma is created when you expose a gas to very high temperatures or when you pass electricity through it. Our most familiar form of plasma is probably the gas inside a fluorescent or neon light bulb. Lightning is an example of plasma on a larger scale. And on a very much larger scale, our sun and all the stars are also made of plasma. Plasma is quite remarkable. It has no specific shape. It's also a bit like a metal in that it easily conducts electricity and produces and responds to magnetic fields. Because of these unique properties, plasma can be tremendously useful, which brings us back to metal cutting. Now that we have a better idea of what plasma is, let's see how it works. Here's the inside of a plasma torch. the kind typically used on cutting tables. Compressed air, nitrogen, or other gases provide a source for the plasma. In this example, a second inert shield gas is used to protect the workpiece and blow off melted metal. Electricity supplies the energy needed to turn the gas into plasma. The greater the current, the hotter the plasma.
In the next moment, you'll see where I've basically taken that machine part, programmed the tool paths, the machine speeds, and then now brought it into the actual software that controls the machine and made sure that the 0 point is correct and begin the actual cutting process. The part can then be removed, and voila! Thanks for watching.